Okay, finishing up number 7 here. Now we're going to go and we're going to reflect over two different lines. Y equals 3. Okay, that's going to be this line right here. So y equals 3 is a horizontal line, starting 3 up from the origin. And then x equals 1 is this vertical line right here. Okay, so let's go ahead and reflect triangle ABC first over y equals 3. C prime is going to land there. A prime is going to land there. And B prime right there. Okay, use your straight edge and finish this off. And go ahead and write the coordinates down. For C prime, we're at -6, 6 it looks like. For B prime, -7, 10. And, whoops, I switched A and B. Sorry about that. Or A and C. It's actually C prime that is -6, 6. A prime is at -2, 8. Alright, I just want to double check something. Okay. Yep. Alright. Just checking the math on those. Basically what I'm checking is to make sure that, if we take the y value, the x values stay. If we took the y values of -4 on C, oh, that's B. -4 and 10, add them together, you get 6. 6 divided by 2 is 3. I was just making sure the y's averaged out to being 3. So that's what I was checking. Alright, so a double prime will land there. B double prime there. So 7, that's C double prime. And straight edge to finish the graph. Okay, so A double prime looks like 4, 8. B double prime, 9, 10. And C double prime over here at 8, 6. And just making sure the math works on those. Yes, I'm averaging the x's out to being 1, if you think about it. So check that out. Feel free to ask me what I'm talking about if you want to hear that explanation. What's a single transformation that maps the original to its image? Again, recognize the same thing. That a double line reflection does, in fact, result in a rotation when the two lines are not parallel. When they are parallel, it's a translation. So we're going to go through and we're going to generalize in a minute. It is a rotation, and what I try to teach my students is the rotation is going to be double the angle between the two mirrors. Well, there's 90 degrees between these two mirrors. So the angle of rotation is going to be double that. It's going to be 180 degrees. Okay, and again, you can check out the videos on that earlier in the chapter. How do you recognize it? Same things. Orientation that is preserved. So that eliminates a single line reflection. Just can't get it done. A single line reflection, we know, does not preserve orientation. And the orientation, again, I'll go through that. It is clockwise if you go to A to B to C. It is also clockwise if you go A double prime to B double prime to C double prime. So that's orientation. Arrangement of the letters. Okay, then we knew again, look at A to A double prime. That is a different distance than B to B double prime. Eliminates, when that happens, Remember, translations need the same distance traveled for every point. So when it's different distances traveled, that idea immediately eliminates translation. And again, so that leaves us with only rotation. Okay? Of course, somebody might argue, well, what about point reflection? Well, point reflection and a 180-degree rotation land on the same place. When we perform other double line reflections with the lines intersecting, you'll see that it's not going to be a point reflection. So, all right. Write the single rule. It's going to be a 180-degree rotation centered at the point of intersection 1, 3. So rotate 180 degrees. The center is going to be the point 1, 3. I'm not going to write the rule for that. That's a little, a little more challenging. I'm not going to take time for that one. Generalize what happens when a figure is reflected in two perpendicular lines. All right, generalize it. It's going to be a rotation first off. Rotation. Oh, two perpendicular lines specifically. Let's get more specific then. It's going to be a rotation centered at the intersection of the two lines. Mirrors, right? Okay? And the angle specifically is going to be 180 for specifically two perpendicular lines. Now I'm going to tell you it's double the angle between the two lines, right? Well, when lines are perpendicular, the angle between them is 90. Double that's 180. Good enough. All right, describe completely. Now, this is something we got to work on. Notice it's probably going to be a 2-point question, but describe completely is more than just saying the word translation. When we score this on our test, those folks that didn't watch this carefully, they're going to answer translation only. That is not a complete description, okay? So complete description. So what I can do is I might go ahead and throw A and A prime here. It gives me something to talk about, or B and B prime. You can make this up as you do this so you can speak to it more clearly, okay? Make up examples. Anything will help your explanation. All right. Now, what I'm going to do is I'm going to go ahead and I'm going to connect B to B prime. Okay? Now, it's going to be a translation with a direction of B to B prime and a distance, or we'll call it distance, B to B prime. Okay? All of them are going to move by the same amount. C to C prime is going to be identical to that, A to A prime. So when you say describe completely, you're trying to give us more than just the word translation. Translation is 1 point. The remainder of it is the other 2. Another way to say it is translate by directed segment. This is a keyword, directed segment. And again, I try to teach my students, make it sound like you were sitting through a math course on geometry. People aren't going to say this unless they've sat through the math course. Use the terminology that has been in our class. Okay, so that's important in the Common Core geometry right there. Translate by directed segment, B to B prime. And if you see that, sorry, it got covered up a little bit. It's the half arrow symbol is what we use in our class. The half arrow, the top part of it. All right. Describe completely the rigid motion that will map the rectangle. Again, I'm going to do the same thing. I'm going to call this A, B, C, D. I'm going to give it points. You can go ahead and do this. Now, to me, okay, left to right. So, okay, basically, you got to be really careful here. If this is A prime, B prime, C prime, and also D prime in the same location, right? We got to be careful of our number for our angle. So here's what I'm going to say. There's a couple options. I'm going to say it's a rotation. Again, that's not enough. That single word by itself is not enough. It needs a center and an angle. So it's going to be centered at point D. And you made that up. You can make up your own letters to use, to identify. So it's going to be centered at point D by an angle. Now you got a couple choices here. By an angle of negative 90. Okay. That's assuming it is, well, it is a rectangle, so yeah, it is negative 90, or positive 270, right? Because technically we are supposed to go in this direction, okay? Actually all the way to there. So that's 270 degrees if you calculate that angle. All right? Good enough for that. So that's more complete. Describe again completely the transformation. There's a couple that are fine. You could say it's a point reflection. So let's just use that because we already did a 180-degree rotation. So if you see it, you could go 180-degree rotation. I'm going to go point reflection through point M. So I'm going to reflect triangle ATH through point M to get triangle DBE. And that's a complete description because you gave the point that you're reflecting through. So good enough there. Describe two sequences of transformations. Oh, you know what? I'll make the next video starting at number 11. Thanks so much.